Hey folks, Ms. Gosling here. In this video, you are going to learn about significant figures. By the end of the video, you will be able to express your answers to practice problems to an appropriate number of significant figures. So let's go ahead and get started. So let's go ahead and start by talking about what significant figures are. So significant figures are a way that we categorize numbers, and any non-zero digit, so that is 1, 2, 3, 4, 5, 6, 7, 8, and 9, is significant. So for example, a number like 174 has 3 significant figures, 1, 7, and 4. Zeros are a little more complicated, however. So there are only 2 cases in which zeros are significant. So first, if a 0 is between 2 non-zero numbers, in the case of 101 or 9.001, those zeros are significant. So this first number has 3 sig figs, and that second number, 9.001, has 4, because the 9, the 1, and both zeros are significant. Now, the only other time that zeros are significant is if they are at the end, if they are trailing, so at the end of a number, and there is a decimal. There needs to be a decimal. So for example, the number 10 only has 1 sig fig, but 10.0 has 3 sig figs. The zeros in 1.00 and in 900.0 are also all significant, with 1.00 having 3 sig figs, the 1 and both zeros, and 900.0 having 4 sig figs, the 9 and all 3 zeros. So, okay, I just spent a whole long spiel talking to you about what significant figures are, but, who cares? Why should I care about whether a 0 is significant? Why does the number of sig figs matter? Well, in science, significant figures are important because they express how precise your measurements and therefore your calculations are. So the way I like to think about it is I like to think about 2 different meter sticks. The first meter stick is a regular meter stick like we have in class, where every single centimeter and every single millimeter is marked out. The second meter stick is literally a stick that is 1 meter long. So with my first meter stick, I can measure things down to the millimeter really easily, right? Because I have markings for 1 millimeter. So that means that on this meter stick, I can easily measure things to the meters, the decimeters, the centimeters, and the millimeters, and still have an accurate measurement. With my second meter stick, however, I can't see millimeter or centimeter markings. Really, I can maybe cut this in half, in quarters, maybe even in eighths if I'm really good at splitting things into pieces. But beyond that, it's much harder to make precise measurements. So while something might be 1.000 meters long with my first meter stick, with my second meter stick, I would probably just say it's 1 meter. Maybe 1.1 if I'm feeling really good about my ability to break this meter stick down into different pieces. Sorry, not 1.1, 1.0. So that is why I care about significant figures. They express whether I was using a precise tool, a tool that has really clear markings, like my first meter stick, versus a tool that is imprecise and therefore and a little bit broader, like my second meter stick. So now that you understand what significant figures are and why I care, let's do a little practice. On the screen, there are 7 numbers, and what I'd like you to do is pause the video, seriously, click the pause button, and see if you can figure out how many sig figs each number has. When you think you know, press play again and we'll go through it. Okay, so hopefully you've paused your video and had the chance to come up with your answers for numbers 1 through 7. Here we go. So 17 has 2 significant figures because both the 1 and the 7 are significant. 402 has 3 because the 4 and the 2 are significant because they're not 0, and the 0 is significant because it's sandwiched in the middle of the 4 and the 2. 500, on the other hand, only has 1 sig fig because it has trailing zeros but no decimal place. So those zeros are not significant. 2006, though, has 4 because our zeros, again, are sandwiched between 2 non-zero numbers. Next, we have 800.10, And for 800.10, all 5 digits are significant because there's a decimal. So that 0 at the end matters. For number 6, 0.002, we have 1 sig fig. This one's tricky, right? There is a decimal. So some of you may have decided that those zeros in front of the 2 are significant. But remember, it's only trailing zeros, only zeros at the end of my number that appear after the first non-zero number that can be significant. So those 3 zeros at the beginning are just placeholders telling me because we can't just have blank spaces before the 2. So they're not significant. However, that 0 in number 7 that's after the 2 is, giving my final number 2 sig figs. So I hope that most of your numbers of sig figs when you did this on your own matched with mine. If they didn't, I hope that you understand a little bit about which of these numbers are significant and why. So the last thing I want to talk about before I finish this video is how sig figs work in practice problems. So the number of significant figures in your answer should match the number of significant figures in the problem. So for example, 1.3 plus 2.0, and I get that my sum here is 3.3. And since 1.3 and 2.0 both have 2 sig figs, I am good to go. I don't need to do any rounding. However, when I have 2 numbers with a different number of sig figs, my answer is going to need to match the significant figures of the number with the fewest sig figs. So what I mean by that is if I have my same equation as before, but instead of 1.3 plus 2.0, I just have 1.3 plus 2. So when I add those together, my calculator is still going to shoot out 3.3. But because 2 only has 1 sig fig, which I'm going to use SF to notate for, my answer should also only have 1 sig fig. So I'm going to round my 3.3 to just plain old 3. And this is your reminder for rounding. If you have 0 through 4 let me back up. So when you're rounding, say I want to round to the ones place, so I have 1.x. If x is between 0 and 4, then I round down. If x is greater than 4, in other words, if x is greater than or equal to 5, then I'm going to round up to 2. If you need help with rounding, come find me. I'm happy to go over this in class. Okay, so before I finish the video, I'm going to do one example of how this is all going to work in physics. So the Go-Go's were going on a road trip and left home at 30 meters per second, driving 400.0 meters. If they came to a stop, then what was their acceleration? So I'm going to fill out my SUVOT table. So their initial velocity is 30.0. They drove for 400.0 meters, and they came to a stop. So their final velocity is 0. And I want to find their acceleration. So to do this, I'm going to use my equation I'm going to use my equation v squared equals u squared plus 2as. And plugging my numbers in, v is 0. That's going to equal 30.0 squared plus 2 times a times 400.0. So simplifying this, I get that 0 is equal to 900 plus 800.0a. Now, I should have a decimal after that 900 to show that all 3 digits are significant. I usually am a little lazy about doing that, but it's good to be precise when we're learning about sig figs. So I'm going to continue solving this just like any other SUVOT question. So I'm going to subtract 900 from both sides, and I get that negative 900 is equal to 800.0a, dividing both sides by 800.0 to get a by itself, and I get that a is equal to negative 1.125. However, now it's time for me to round. So I'm given 2 numbers here, 30.0 and 400. Now, you'll notice I also have my velocity as 0, but this 0 actually has essentially an infinite number of sig figs because it's 0.00000000 forever. So we're not gonna count zeros when we're not gonna count numbers that are just zero. So if velocity is 0 or initial velocity is 0, we're not gonna worry about that for sig figs because that kind of has both 0 sig figs and infinite sig figs at the same time. So instead, we're gonna look at the two numbers we're given: 30.0, which has 3 sig figs, and 400.0, which has 4 sig figs. Since 30 has fewer than 400, I'm going to round my number to 3 sig figs, giving me negative 1.13, because that 5 is going to cause my 2 to round up instead of down. And there you have it, guys. That is how we use sig figs to appropriately express the precision of our answers. So with that, let's go to takeaways. First of all, non-zero numbers are always significant, but zeros are complicated. We have rules for when zeros are significant. Second, the number of significant figures matters because it expresses how precise your final answer is. And finally, your answer should have the same number of significant figures as your givens, and we always err on the side of fewer sig figs rather than more sig figs. So there you have it, folks. There is your notes on significant figures. I hope that this was an interesting experience. In the future, I am going to expect that every problem that you do, you answer with the right number of sig figs. So I hope that you guys are able to really understand this video, and if you don't, please come find me. I'm always happy to go over it. For now, go ahead and get started on some practice. Best of luck, and happy solving.